Hello students. Now we're now going to have a go at exercise 3.7 question 3. So this is a multiple choice question, and we do have these on the external exam, so they're worth practicing. So consider the function f of x equals x squared natural log of x. And the question A is, where does the graph of the function have stationary points? So there's the function written down just there. Now stationary points, I'll just do a bit of a drawing here. Stationary point basically just means this. You've got a function just there. Here the gradient is positive. Over here the gradient is negative, and right there is what's called the stationary point. When it's no longer rising, it's no longer falling, it's just horizontal. So that maximum is a stationary point. The other stationary point, another stationary point, is a minimum. So here the graph is falling, here it's basically stationary, and here it's rising. So another place where you can have a stationary point is at a minimum. And finally, if you think of the old y equals x cubed function, oops, that's not drawn very well, something like this. Here it's rising, but it's rising slower and slower and slower. Just for an instant, it reaches a gradient of 0, so that's called a stationary point, and then it starts rising again. So these are all called stationary points, and the important thing about stationary points is the derivative equals 0. So that might be enough information for you to stop the video and have a go on your own, please. Again, pretty much now you know that you just have to find the derivative, set it equal to 0, and solve for x. So let's go and see how you went. Okay, now we've got a function times a function, so we need to use the product rule for this. So it's the second function times derivative of the first, plus the first times derivative of the second. Again, you might want to stop and see if you can do that yourself. Okay, so the second function is natural log of x. The derivative of x squared is 2x, plus the first function is x squared, and the derivative of natural log of x is 1 on x. So that leaves us with that expression in blue. And of course, I've got two x's on top, one x on the bottom. I can cross out or cancel one factor of x, and that leaves me with just that. So step one, when you're asked to find a stationary point, what you have to do is find the derivative. Okay, let's move on from that. What do we know about the stationary point? Well, we know the stationary point, the derivative is equal to 0. So basically what I've got is that function just there equals 0. So this 2x, maybe I should have brackets around that still. I'll put the brackets around it. 2x natural log of x plus x equals 0. So solve that equation for x. Again, you may want to pause the video. The more you do on your own, even if you find it difficult, the more you're going to remember, the more you're going to learn. So that's what I suggest you do. Okay, now the secret here, because we basically want to solve it for x, if you got an x in two different terms, added or subtracted, the trick is take out a common factor. So get all your x's together on the same side of the equation, which I have, and take out the common factor of x. So I've taken that factor out and that factor out, leaving 2 times natural log of x in brackets, and x times 1 gives x, so a 1 in brackets. So now I've got the x outside of the brackets. The next step is to say either that factor equals 0 or that factor equals 0. So whenever you've got something times something equals 0, each of those can equal 0. So that's where the next line came from. So there's one solution. And to solve this one, again, you might want to stop the video and see if you can finish that one off. Okay, so all I've done there is I brought the 1 to the other side to make it -1 and divided by 2. So log to the base e of x is -1/2. And then rewrite that as an exponential. So x equals e to the -1/2. And you can write that as x equals 1 on the square root of e. The reason for that, of course, is the negative index brings it to the bottom of a fraction, and e to the 1/2 is square root of e in this case. So it looks like we might have two solutions. It looks like we might have x equals 0 and x equals 1 on the square root of e. But before you can actually put a tick on both of those, go back to the original question. And one of the factors in the original question is natural log of x. Well, that's a positive number, so that's a valid solution. But x equals 0, the natural log of 0 doesn't exist. So even though that's a solution to this equation, it's not a solution to, or not a value you can put into the original function. So that has to be crossed out. And final answer is just x equals 1 on the square root of e only. Final answer, therefore, is B. So we'll stop there. That's question 3A from exercise 3.7.